This video goes with Unit 12, which is thermodynamics. The essential questions are what is specific heat and how do you calculate it, and what is calorimetry? So first we're going to talk about how to calculate an enthalpy change, which is delta H. We're going to use an idea called calorimetry, which basically traps all the heat in one place. This is an example of just a coffee cup calorimeter. It's using a styrofoam cup with a lid. So that's a pretty simple one. So we're going to use this Q equals mc delta T, or delta H equals mc delta T. You're going to see the Q most often. Okay, the M is going to stand for mass. The C is going to stand for specific heat capacity. And delta T is going to be the change in temperature from final minus initial. And then the Q, or the delta H, is the heat. So a specific heat capacity, we're going to revisit that, is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay, so it's different for different substances. So let's look at a practice problem. The heat released from burning alcohol is used to heat 100 grams of water from 24 to 39 degrees Celsius. How much heat was released from the burning alcohol? We can look up the specific heat of water. It's 4.18 joules per gram per degree Celsius. That means for every gram of water you have, it's going to take 4.18 joules to heat that up by 1 degree. Okay, so I have my equation. My mass, if I look in my equation, was 100 grams. My delta T is 39 minus 24. I need to subtract those to get that. And then I have C is 4.18 joules per grams degrees Celsius. So the first thing I need to do before I do anything else is subtract that, and I get 15. Then I can just multiply this out. So 100 times 15 times 4.18, and I get 6,270 joules. Or if I want to change it to kilojoules, it's 6.27. It's negative because it's releasing the heat. Okay, and all my units are going to cancel out. My grams cancel out there, my degrees Celsius cancel out there, and so that's what gives me joules at the end. Let's look at another one. An experiment is done to determine the heat of reaction between solutions of sodium hydroxide and hydrochloric acid. The temperature of each solution before mixing is 26 degrees. 100 grams of each solution are added to a calorimeter and the temperature of the mixture rises to 32 degrees. Calculate the enthalpy change for the reaction. Again, we're going to assume that the specific heat of the solution is 4.18, just like water. So I'm going to plug in. It says that I have 200 grams because I have 100 grams of each, so that's 2. It goes from 26 to 32, so I'm going to subtract that, and then I'm going to use 4.18 for C. Okay, so the first thing I need to do again is subtract, so I get 6, and then I'm going to multiply 200 times 6 times 4.18. That's going to give me negative 5,016 joules, or if I want to round that into kilojoules, that would be 5.02. And again, it's negative because it is losing heat. Your grams are going to cancel, your degrees Celsius are going to cancel, and it's going to leave you with joules. Okay, so now let's talk about calorimetry a little bit. It's the process of determining the specific heat of a substance by using that specific heat idea. Our idea is that heat loss is equal to heat gain, so it's a closed system, which is like the coffee cup. It's not letting the heat escape. So that's the main idea behind the calorimetry. So let's look at a problem. A blacksmith lowers 3.2 kilograms of an unknown metal at 130 degrees Celsius into 22 liters of water. And since we're in kilograms, we're going to use 4,186 joules. The initial temperature of the water was 43.5 degrees and the final temperature is 45. What is the specific heat of the unknown metal? So the idea is that heat loss is going to be heat gain. We can't lose the heat altogether. It's going to stay in the system. So I'm going to put mc delta T on both sides, and the hardest thing about this is just keeping track. So on the left, I'm going to do the metal. So I had 3.2 grams of metal. I don't know the specific heat of the metal, so that's going to say C. The metal started at 130 and ended with the final temperature of 45. Okay, so that's the red side. On the blue side, I'm going to do all the water. So I have 22 liters of water, which is also 22 kilograms, so that's my mass. It gives me C, 4,186. It says that I started at 43.5 and ended at 45, so those are my two temperatures. Okay, so the first thing I want to do on both sides is subtract and then multiply. So I end up with 272 C on the red side and 138,138 on the blue side. Now I'm just going to divide both sides by 272, and I am able to find the specific heat of my metal. So I get 508 joules for every kilogram and for every degree Kelvin.